Yes, welcome you all for another presentation on random variables and random processes subject. This is the lecture number 9. In today's lecture, I am going to explain you few examples questions that we will see based on the probability distribution function and then probability density function. What kind of questions normally will be expected in your regular examination as well as competitive examinations, right? So far we have covered the brief information or definitions or information about the probability distribution function as well as the probability density function, and we have seen their properties also, right? In today's presentation I would like to explain you few examples actually. Okay, let us see the first example, as you can call it as some question number 1. Okay, so here the probability density function, so the PDF means the probability, okay, the probability density function, the probability density function, always remember the probability density function is definitely should be written as small PDF only and is denoted by small f of x. Always remember that small f of x is given by, means the probability density function of random variable. I simply can write it as random variable x. Random variable x I can write like that, random variable x, and is denoted by small f of x is equal to, it is k into 1 minus, it is something x square. The function is given like this, k into 1 minus x square, for the limitations are for 0 is less than small x is less than 1. It is between 0 to 1 and it is given as it is 0 elsewhere. It is 0 elsewhere, which means other than these intervals, means below 0, above 1. So other than these two limitations, this function becomes f of x becomes 0. That is the meaning of it. Then you are asking that find, the question is find the value of k. You will be asked find the value of k. The constant k is there in the function. This is the density function. Okay, we have to find out the value of k. And second one is the PDF, is the PDF valid, is the PDF is valid or not, is the given density function, is it valid density function or not? That is what the question is, right? So the distribution is given like this, f of x is equal to k into 1 minus x square, and this function is defined over the interval 0 to 1. How to solve for k? So, right, this is easily solved based on one of the very important property of our density function. If you recall from our previous presentations, right, I am going to solve this problem. If you write the solution part of it. So what is the very important property of density function? So always remember that if in the given problem, if certain constant is given like this in this problem, you should remember that the second property of the PDF density function, what is this? This is minus infinity to plus infinity. The density function f of x into dx must be equal to 1. That is the second property. What is the first property? The first property is f of x. Clear? So f of x should be greater than 0. This is the first property. It is a non-negative function. The density function of a random variable x is a non-negative function. This is what the first property actually. Remember that. However, this is not required to solve this problem. We need the second property. The second property says this. If you evaluate the density function over the interval, the okay, the integral of the density function should equal to 1. Clear? Now, so from this property, this implies, now what I should do, what are the limitations? What are the x limitations? It is the integral of f of x into dx. Therefore, x limitations we should need. So, it is already given in the problem. It is given as 0 to 1. What is your f of x? What is your density function given? It is k into 1 minus x square into dx must equal to 1. Clear? Must equal to 1. Now you can little bit expand this. You can little bit expand this. The next step. What is the next step? So this implies I will erase this also, not required now. And this implies it is 0 to 1. Clear? K into 1 minus x square dx is equal to 1 actually, and afterwards this is equal to you can write like this, 0 to 1 k into dx. Clear? Just you separate two terms like minus is there, integral 0 to 1, what is this, k into x square dx is equal to 1. Or otherwise, in both these things k is there, you can take k as common, otherwise take outside. If you take k as common in both these terms, then what you will have actually, it is 0 to 1 dx minus 0 to 1, it is x square dx is equal to 1. Then what you will have, this implies it is k bracket. So integral of derivative, integral of dx. So remember that the integral derivative both are opposite to each other, both will be cancelled out. Then what remains, x will be there. So for this x you need to apply the lower limit and then upper limit, minus it is integral of x square. What is the integral of x square? It is x cube by 3. It is not. So 0 to 1. So finally is equal to 1, right? And furtherly, if you apply the upper limits and lower limits in that expression, and what you will get? So here, so the next step will be like this. This implies k into in x, substitute upper limit 1 minus 0, therefore it is 1 minus 0. Clear? Minus, so in x cube substitute 1, so it is 1 cube by 3, it is 1 by 3, minus 0, however it is 0, this is equal to 1. This is equal to k, 1 minus 0 is 1, minus 1 by 3 is equal to 1. This implies what you will get, k is equal to 3 into 1, 3 minus 1, 2 by 3 is equal to 1, and finally you can write that your k is equal to, what is the k is equal to? This implies k is equal to, take this 2 by 3 right side, then it is 1 by 2 by 3, or otherwise it will be 3 by 2. This is the answer. This is your answer. Therefore, what is the constant k? Constant k value is 3 by 2. Clear? This is the k value you have to find out from the second property of the density function. Clear? Now, this is the first bit is over. Now, coming to the second one. What is the second bit? Is the given PDF is valid or not? Sometimes in examination it will be asked, right? For the second bit, is the PDF is valid? Is the given PDF is valid or not? Is valid or not? Clear what we need to do for this? So in order to verify the validity of the density function, again you must need to evaluate the integral, that is minus infinity to plus infinity f of x into dx. See that this integral you should get your answer as 1. Clear? You should get the answer must be equal to 1. In previous case, in finding the constant k, the total, so the total property we are considering, and from this property we are simply we can obtain the value of k. But whereas in order to find out the validity of the given distribution function, we need to evaluate this integral part and see that whether your answer is 1 or not. So you must get the answer is 1. Then only if the answer is 1, if this integral part of the f of x dx must be 1, then you can say that the given density function is a valid density function. Otherwise, if you get something other value other than 1, definitely it should not. It is not a valid function. Now check for the given problem. So now it is, what is the limits? This is in general for a continuous random variable which is defined over the interval minus infinity to plus infinity. This is the general definition of a probability density function. Whereas for the given problem, you simplify, you can apply the limit 0 to 1. What is your k? K is nothing but it is 3 by 2, no? It is something 3 by 2 into, what is that? 1 minus x square. 1 minus x square into dx. Now evaluate this integral part. Evaluate that integral part. What is your answer now? Tell me. So evaluate this part. So if you evaluate this, definitely this is equal to, this implies what you will get, it is 3 by 2 is constant actually. Therefore you will get something integral of dx. It is 0 to 1. It is minus. It is integral of x square dx. 0 to 1. Is it not? This further is equal to 3 by 2. What is this? Again both will be cancelled out. Only x you will have here. It is 0 to 1. And here x square is nothing but x cube by 3. And substitute 0 to 1 here. Clear? And this implies the second step. What is that? It is 3 by 2 of, it is x. So in place of x, substitute upper limit minus lower limit. It is 1 minus 0, upper limit minus lower limit, minus 1 by 3. And it is something 1. Again, it is 1 cube by 3 is 1. Definitely it is 0 and definitely we will get 0 there. Therefore, this is equal to 3 by 2. And then 1 minus 0 is 1 minus 1 by 3. 1 minus 0 is 1. 1 into 1, 1. 1 by 3. This is equal to 3 by 2. This is equal to 3 into 1, 3 minus 1, 2, 2 by 3. Therefore, 3 by 2 into 2 by 3. So, 2, 2 cancel, 3, 3 cancel. Finally, you will have your integral as 1. Your answer is 1. Therefore, the given density function is a valid density function. Likewise, we have to calculate. Clear? Therefore, the given density function, okay, that is what means that the given density function, what is the density function? That is fx of x, substitute that k value, it is 3 by 2 into 1 minus x square over 0 to x is less than 1 is a valid, you have to write a valid density function. Valid density function. This is what the answer. Clear? I think we will finish this presentation here and we will continue with some more examples in the subsequent presentation. Okay, thank you for watching and we will continue in the next presentation. Have a beautiful day.